Okay, cybersecurity students, this is Mr. Sparks. We're going to be covering 3 lessons actually. They're very short, but this lecture will cover all 3 topics on files, Linux files and directories. And then there'll be 3 separate labs. They won't be all due at the same time, but we're going to kind of cover all of them. And as I get those posted in the next few days and weeks, or into next week, I'll put a little short video covering the lab and what you need to do. So this will be the lecture covering all the commands and what we'll be doing, and then there'll be a little short video attached to each lab assignment that you can just kind of view. Shouldn't be very long, just kind of covering the topics and kind of how you need to do things. So we'll go ahead and get into our lesson. Okay, so this is 3 separate lessons. They're fairly short, so we're just going to kind of cover each one, and then there'll be labs that you'll get a chance to do to practice all these techniques. Okay. All right. So the first one is going to be dealing with zipping and unzipping files in Linux. So Linux, just like you would zip or compress in Windows environment, this pretty much is what you'll be doing, how you do it in Linux. So several ones that you can use in Windows may be like WinZip, 7-zip, WinRAR, and just the compression feature on Windows when you right click and say send to compressed folder. Same concept, and then when you unzip it, you're just basically uncompressing these things. So we're going to go over how you do that here in Linux. Okay, so the objectives is going to be understand how to zip them in a Linux file system, and then how to unzip those files as well. Okay, so we're going to talk about zipping files first. So in Linux, there are several different ways to zip or compress files. In this lesson, we'll cover the most common methods, which includes creating a tarball with the tar command, zipping files with gzip and bzip commands, and unzipping files with gunzip and tar. Okay. All right. So first, we're going to talk about tar. So the basic tar command creates an archive, or it's also known as a tarball, which is nothing more than just taking a group of files and putting them together in one file without using any kind of compression. So this basically just puts them together, doesn't compress them or reduce the size or anything like that. Okay, so the tar command can be used also to compress the tarball archive using the bzip and the bzip2 algorithms. Okay, so the basic syntax of this tar command is going to be tar and then dash and the options that you choose, then the name of the archive that you want to put these files into, and then a list of files that you want to archive. So basically, the tar command will tell it and what option of what you need to do, and then it will give it a name to store these files in, and then any files that you want to include. Okay, so here's some of the options that you use with the tar command. -C will create your archive. So if you do tar-c, that will create the archive. If you also use -z, that will compress it with the bzip algorithm. If you use -j, that's going to compress it with the bzip2 algorithm. You've got verbose, and you've got -f for the file name of the archive. Okay, the resultant file name will end in .tar, which indicates a tarball. If the tarball is also compressed, it will end in .tar.bz if you're using bzip, and .tar.bz2 if you're using the bzip2 algorithm. Okay, so all the original files will remain in your directory where they were located. So just kind of like when you do in Windows, if you think Windows, if you were to right click on a folder or a group of files, and you say send to compressed folder, and it will take those files and basically copy them into a compressed folder when you zip them, but the original files still stay in their original location. Okay, so similar concept. This is just a different way to do it in this Linux system. Okay, so here's a good example. The tar command requires the -cf options to create your tarball. The -c option means to create an archive, and the -f option identifies the archive name. Okay, create a tarball does not reduce the size of the files because no compression algorithm is used. So if you're just using tar, you do not compress them. So you see the example there, it says tar-cf files.tar is the archive name, and then file with the wildcard asterisk means any file that has file and any characters after that will be included in this. Okay, and then when you go to once that is complete, you do your ls-l on files with an asterisk. It will tell you here in this example that files.tar is the only one you have. So it did successfully do that. Okay. All right, so another example. The tar command requires the -czf options to create a tarball that is also zipped using bzip. So that file extension should be tar.bz. Okay, depending on the types of files in the tarball, the size of a zip tarball can be significantly smaller than just a regular tarball. So you see the command there is tar-czf files.tar.bz and then file asterisk. So it gives you the option to do all those in a zip format. And then if you do your ls-l on files with a wildcard, you get files.tar and files.tar.bz, which would be the compressed version. And if you look at the permissions and owners and then the file size, you'll notice that on the first one, the files.tar is the size of the file is 10,240 bytes, but the compressed version is only 269 bytes. So you can see a significant difference in the file size. Okay. All right, the tar command requires the -cjf options to create a tarball that is also zipped using bzip2. So the file extension should be tar.bz2, and basically the same file or same command. You just have cjf instead of instead of the other one. Okay, and basically you get the same scenario there, and you get the files.tar.bz2. Okay, so pretty similar. You just which option you decide to choose. All right, next, the tar command can be used to unpack tarballs that end in .tar and unpack and unzip files that end in tar.bz or tar.bz2. So that would be tar dot or dash xvf and then the tarball name. So you see in the example here, it says tar dash xvf files.tar, and then the resulting is you have, in this case, file 1, 2, 3, 4, 5 were the files that were actually archived in that .tar file. So it will list the files that you had in there. Okay, so let's talk about gzip. The gzip command can be used to zip a single file or also multiple files. The basic syntax to zip a single file is gzip and the file name. Okay, basically you would use this if you just wanted to create a compressed version and you didn't want a tarball archive as well. You would just use the gzip command to start with. Okay, so your file output will have a .gz extension, and the original file will no longer be in the directory. So basically what this will do is this will take this, if you just use it this way, is it basically will just zip that file in a compressed file, and then it will not be available any longer. In its native format. You would have to unzip it again to be able to access it when you use this command this way. So just be aware of that particular option there. Okay, gzip. To keep the original file when using gzip, the syntax is gzip-c file name, and then your greater than symbol, and then you give it a file name.gz. So if you want to keep the original file, you don't want it to be just contained in the zip, then you can add these options when you do your gzip command. So there's usually always multiple ways to do things in Linux. It just depends on what you're actually wanting to do. Okay, so you see here it says gzip-c file2 send to file2.gz, and then you ls-l file2 asterisk. You will get file2 and also the file2.gz. Okay. So that's your difference in how those things work. Okay, to zip multiple files using gzip, the syntax would be gzip-c, then the file names, and then what gz file you want to send it to. Okay, the file names to be zipped are separated with a space. So you see here gzip-c, file 2, then a space, file 3, space, file 4, send to files.gz. Pretty simple. You just got each file. You could put 10 or 15 files here. All you need to do, doesn't matter if your command goes on multiple lines. You just put a space in between each file name that you want to include. Okay, gunzip. Gunzip command can be used to unzip files that have been zipped with the gzip command that end in .gz. So the basic syntax of the gunzip command is gunzip and the archive name. Pretty simple. Just type it in, files.gz, and it should unzip those files for you. So pretty straightforward, nothing super complex. Okay, so that's pretty much all for that particular lesson. That will be a lab by itself. It'll be the first lab that you'll be able to complete. Should have that one ready by Friday, and maybe sooner. But I will probably include a short video just explaining the different tasks in your lab. So I'll include that with the assignment, so you might just won't be near as long as this video, but I will include a little short video with each lab that you'll be required to do. Okay, so that takes care of that lab and zipping and unzipping files. Pretty simple process. All right, so the next one is lesson will be file links. This will be 2 of 3 lessons today. Okay, the lesson objectives is to understand what an inode is and understand how to use a hard link in the Linux file system and understand how to use a soft link in the Linux file system. Okay, so inodes. So each file and directory in the Linux file system has an inode. Okay, an inode is just a number that refers to a file or directory in the Linux file system. Inodes store the basic information about a file in the Linux file system, and the Linux operating system uses inodes to access files and directories. So we're going to look here what is actually stored here. So the following information is found in an inode for a file: the location of the file on the hard drive, so where it's located, the type of file that it is, what its permissions are, who the owner is, what the group is, what the file size is, the file access time, the file change time, file modification time, and file deletion time. So it gives a lot of information that you've already seen before as far as permissions and owners and groups and file sizes and things like that. Okay, so the file name or directory name is not part of the inode information. So this is because the file name and directory name is just a link to an inode. So the name of it is just a link to the actual file location. Think of that kind of like almost, I guess it's just a reference point. And it's a lot easier for us to remember words and names than it is to remember numbers. Okay, the file name or directory name is associated with an inode in your directory. Okay, the inode points to the actual file or directory where it's at. In the Linux file system, a directory is a file that lists the file names and inodes associated with those. Okay, so here's an example. Okay, you can view the inodes associated with a file name or directory name by using the ls command with the -i option. So if you see here, you'll see desktop has a number, an inode number that's 408387, and documents have numbers. So all these have numbers associated with them, so it'd be a lot easier to remember desktop documents downloads than 408.387, 524.346, or 524.343, and so on. So words are a lot easier for us to understand. Computers seem to like numbers much better. Okay, all right, a hard link. So in the Linux file system, a hard link is the association of a file name or directory name to an inode. Every file in the Linux file system has at least one hard link. Okay, a file can have more than one hard link though. And when a file has more than one hard link, all of the hard links are associated with the same inode. Okay, hard links cannot be created for a directory, so just files. Okay, so if you use the ls-l command, it shows the number of hard links each file in a directory has. So the number of hard links is found in the second column following the file permissions. So you'll have permissions, with the owner group and others, and then you'll have the hard link, and most of the time it's going to have one, and then you'll have who the owner is, who the group is, file size, and so on and so forth. Okay, so using -L, you'll see that listed there. Okay, so the ln command is used to create a hard link, and the syntax will be ln, the original file name, and then the hard link file name. Okay, the original file name and new hard link file name both point to the same inode or file in the Linux file system. Okay, so you can say here ln file 1, and then that would be the file name, the original, and then file name file 1 hard link, and then if you go ls-li, you'll notice that these files now have permissions, and now they have two hard links. So each file will reference the other. But the one thing you need to look is in the far left-hand side, right in this area right here, you'll see that this is the same inode number associated with both of these files. Okay. All right. So once a hard link to a file has been created, either the original file name or the new hard link file name can be used to access the file. So even if the new hard link is moved or to another directory in the file system, the new hard link will still reference the same inode or file. So if the original file name is deleted, the file will still exist with the new hard link file name. So if you delete the original, you still have the hard link file name, then it will still be available that way. Okay, soft link. So another type of link is called a soft link, and a soft link is like a file shortcut. So just like you would have a shortcut icon on your desktop to double click to open up a program or a file or something like that from Windows, that's what a soft link is. So a soft link, it does not have the same inode as the original file, and a soft link just points at the original file. So if the original file is deleted, the soft link will no longer work, and a soft link can be made to a directory. So just like if you were have a shortcut on your desktop in Windows and you delete the actual file and you try to double click it, you'll get, okay, cannot find the file, path is wrong, something like that. So that's pretty much how what a soft link does. It's just like a shortcut in Windows. Okay, the ls-s command is used to create a soft link for the file or directory. And the syntax is ls-l, the original file name, and then, of course, the soft link file name. All right, the original file name and a new soft link file name does not point to the same inode. Okay? All right, a soft link will show the association to the original file when viewed with the ls-l command with a dash and greater than characters. It says in Ubuntu Linux, a soft link will be light blue. Okay, a soft link will have an L in front of the permissions, which indicates a link. So if you look here, when we're doing ls-li, you'll see we're looking at file 1, and we also have file 1 soft link pointing to file 1. So if you notice right here, this is the original file, and this is the soft link. So the soft link here has a separate inode number. Here it's not the same as the hard link one. It has an L right here. That tells you that it's a soft link. It has all the permissions, and here that has all the permissions. Even though these permissions are on here, all this means is that you could actually access the file. So everyone could execute the soft link, but they would still only have the original permissions on the file. So this one only has one hard link. It says student 5th of December, which is this the timestamp, and then this here is pointing to file number 1. Okay. All right. If the original file associated with a soft link is deleted, the soft link will remain, but will be broken, as it no longer refers to a file. It says in Linux, a soft link that is broken will be read. So in this case, where we deleted the file, we'd use the rm file 1, and then look at it. The soft link's still there, but it is now read because that file no longer exists. Okay. Deleting links, both hard and soft links, can be deleted using the rm command. If a file only has one hard link and it is removed with the rm command, the file will no longer exist. Deleting a soft link breaks the association of the soft link with a file, but it will not delete the file itself. Okay, That's pretty much all you have to know about this particular lesson. As I said, these were short, so that's why I just kind of combined all three of them together to cover them. But the labs will be a little bit more in depth and give you plenty of practice to get used to doing these types of operations in Linux. Okay, so the last one is dealing with file information, just information about a file. We've only got two commands to learn for this one, so you understand how to use the file command and to view file information, and then understand how to use the stat command to view file information. Okay, so file information in Linux, it has these two commands, file and stat, and we're going to learn how these things do. Okay, so first, file. The file command is used to test a file to find out what type of file it is. So this example shows the file command being used to identify a directory. So if you just type in file and in the name of the file directory that you're looking for, it will tell you my new directory is a directory. So if it was a file in the next example, so that's pretty much all there is to figuring out what it is. Okay, this example shows the file command being used to identify an ASCII text file. Okay, so ASCII stands for American Standard Code for Information Interchange. All right, most of your text files in Linux are ASCII text files, as it is a standard for displaying text on computers. So most of your text files are going to be that type of file. So if you see here, we do file 1. File 1 is an ASCII text file. Okay, pretty simple. You're just trying to figure out what kind of file it is. All right, this example shows the file command being used to identify a Linux command sudo. So ELF stands for Executable in Linkable Format, which is a standard file format for executable files. Okay, LSB stands for Least Significant Bit, which deals with how the data from the file is stored in memory. So if we do file and in the location of where your file is, and remember you can find these from the previous lab we did when using your finding files. And you'll see here it says if we go file user bin sudo, it tells us that set UID ELF 64-bit LSB shared object. It gives you a whole bunch of other information that may be useful in certain cases. For right now, probably all this information here probably doesn't mean much when you're just learning Linux. But this is how you can actually look at a command and see all the things that it does. Okay, so stat command. Stat command is used to display file system information about a file or directory, such as file name, size, the number of blocks used on the hard drive, the inode number, permissions, the owner, the group owner, and then of course the last accessed, modified, and changed date and time. So here'd be a good example of how that works. You got stat file 1, and it says it's file 1, gives you the size, gives you the number of blocks on your hard drive, the IO block, regular file device, gives you all this information, the inode number, number of links, and then all the different information here about the permissions and the user ID and group ID and everything like that. So pretty much anything that you might need to know about the file, this is pretty much all you need to use to find out that the information. And that was a very short lesson, so you can see why I kind of included all of them together. So you will have adequate time to do your labs. For my in-school students, I'm probably going to allot a class period day. So probably do the first lab on Friday. Then the following lab would be due on Tuesday, and then lab 3 by next Friday. So you'll have about a week or so you have plenty of time to do these labs. You can do them all as soon as you can, as soon as they're posted if you'd like. If you have any problems or any questions, anything you don't understand, please let me know, and we'll get these labs, and I'll be, like I said, I'll include some little short video instructions on how to complete your lab.